I'm Nguyễn from Vietnamese German University in Bình Dương, Vietnam. In this video, I'm going to introduce to you the work performed together with Manuel and Clavel on model-based characterization of fine-grained access control authorization for SQL queries, recently accepted in the Journal of Object Technology JOT of 2020. This is a special issue dedicated to Professor Martin Gogola from the University of Bremen, Germany. On behalf of Manuel and Clavel, it has been an honor to submit our paper as a tribute to Martin, who has made a significant contribution in the world of software engineering. Personally, I would like to say that you have been an inspiration for myself. Some of the tools that you built, like the UML-based specification environment, has been used as teaching materials in academia and as a useful modeling tool in practice. And I am sure you will keep being an inspiration for younger generation. Also, I would like to take this opportunity to thank Antonio, Alfonso, Bernhard, Lars, and Richard, and the rest of the JOT editor team for your relentless effort trying to organize this event under the current circumstances due to the pandemic. Thank you so much. So, model-driven engineering is a software development that focuses on creating models of different system views from which artifacts are automatically generated, like code or configuration data. In other words, model-driven engineering switches the attention from writing code manually to designing models in order to reduce the work of the software developers and to increase the quality of the software being made. In the past, proponents of model-driven engineering have been guilty of making over-ambitious claims. However, there are specialized domains where this methodology can truly deliver its full potential, namely in the domain of security. In particular, model-driven security is a specialization of model-driven engineering to the domain of security. The crucial part of the specialization includes precisely documenting or modeling security requirements together with design requirements, analyzing it, and then generating executable code from it. In this paper, we propose a model-based characterization of fine-grained access control authorization for SQL queries. Particularly, we use a well-known security model called SQL to model out fine-grained access control policy. SQL is a modeling language used in the field of model-driven security for specifying this kind of access control policy. Typically, these policies are specified using object constraint language. Using SQL, one can then model access control decision that depends on two kinds of information. On the one hand, the static information, namely the assignment of user and permission to rows and the row hierarchy, and on the other hand, the dynamic information, namely the satisfaction of authorization constraint in a given system state. Then, given a specific SQL query and an execution user, we formally answer the question whether the given user is authorized to execute a given SQL query according to the given access control policy. Given the following university model example, in which consists of lecturer and student, both represented under their name and email. Let enrollment be the association between lecturers and students, in which a lecturer can teach 0 or many students, and vice versa, a student can enroll in 0 or many lecturers' classes. Consider the following fine-grained access control policies. First, any lecturer can know his or her students. Second, any lecturer can read his or her own email, as well as the emails of his or her own student. Third, any lecturer can read his or her colleague's email, in which two lecturers are colleagues if and only if there exists at least one student enrolled in both of their classes. These authorizations can indeed be expressed in OCL. For example, the second policy can be expressed as color equal to self or color.student include self, in which the color is the subject who is attempting to perform the read action, and the self is the object whose email is attempted to be read. Next, we consider a simple scenario where there are 5 students, Nam, Thanh, Châu, Hoàng, and An, and 3 lecturers, namely Hiếu, Hương, and Manuel, in which Hiếu is a lecturer of Nam and Thanh, Phước is the lecturer of Thanh and Châu, and Manuel is the lecturer of Châu, Hoàng, and An. Now, consider the following SQL query. Select email from lecturer where lecturer ID is equal to Manuel. Given the scenario as above without any security enforcement, the result would be the email of lecturer Manuel. Using our model-based characterization, the result would be the same for lecturer Manuel and lecturer Hương. For lecturer Hiếu, it will signal an error, since according to the fine-grained access control policy, Hiếu cannot read the email of Manuel. Notice that even Hiếu can know that there is a lecturer named Manuel, but he is not authorized to read the email of Manuel. Consider the next SQL query. Select student from enrollment where lecturers is equal to Hương. Given the scenario as above without any security enforcement, the result would be the name of the student, or to be precise, the ID of the student who enrolled in lecturer Hương class. Using our model-based characterization, the result would be an error signaling for any lecturer that is not Hương attempting to execute it. Notice that this also be the case where Hương has no student. The same result still holds since our method checks authorization rights for all possible association links, including the ones that do not exist yet. Finally, consider these following SQL queries. Given the scenario as above without any security enforcement, the result of the two queries would be equivalent and be the emails of lecturer Hương being repeated as many as the numbers of students she has. Using our model-based characterization, in the first query, the result would be an error signaling for all lecturers that try to execute it, also including lecturer Hương. But in the second query, lecturer Hương is the only one who can execute it. Notice that even in the case of the two queries that are equivalent, given the same executor, like Miss Hương in this case, the result may differ since our method does not evaluate the authorization rights based on the final result of the execution, but also from all the temporary results on the go. To the best of our knowledge, this seems to be the first attempt to apply a formal method in characterizing fine-grained access control authorization for SQL query. We would like to continue this line of research in the following direction. First, we would like to extend our formal characterization. On the one hand, we would like to cover as much as possible the SQL language, including left and right join, group by, or aggregate function. On the other hand, we would like to work with another data action, such as insert, update, or delete. Second, with the efficient low-code solution from OCL to SQL, it will certainly open up another possibility of realizing this formalism. For the interested reader, we include our small prototype of this formalism in this slide. Finally, in addition to the realization, our future work will also include proving its correctness. For further detail, we kindly invite you to read the full version of our paper. Thank you for your attention, stay safe, and goodbye.